Hello and good morning. We're going to try to work through this practice test here. It says state whether or not the triangles are similar. There's three ways to prove similar triangles. And if you look here, this side right here is the smaller here. This one is the smaller over here. So I'm going to put 16 over 8 and see if that's equal to 64 over 32. And I think 8 goes into 16. That's going to be 2 times, that's your scale factor. And then this one is going to be 2 as well. So this is going to be side, angle. See how the angles are equal? Side, angle, side, similarity. Okay? So what happens here is the angles have to be equal, but the sides must be proportional. So your scale factor is 2, and it's consistent with both sides. This one right here, I would use the track method to find A, and then use that to find B. So watch the track method. I would go 4 over A equals A over 16. So I'm going to get, I think that's 64 is equal to A squared. So A is going to be the square root of 64, which is 8. So this side right here is 8, and then I would use Pythagorean's theorem and pull that triangle out just to see it. And since it's 8, these are my legs, so I would color it, and I would get 8 squared plus 4 squared is equal to x squared, which, or in this case, is b squared. So b is going to be the square root. Let me make it a little bit bigger. All right, so this is going to be 8 times 8 is 64, plus 4 times 4 is 16. When I add that up, I think I get 80. So it's going to be the square root of 80 on B. So press 80, shift, square root, and I get 8.9. And that's how you do it. It is the track method on that one. Number 3, let's take a look at it. It says UV is 4. And so UV is right there. UT is this other one. That's 6.25. And I'm going to use the track method to find this one. So I'm going to say 6.25 over x equals x over 4. Cross multiply, you're going to get 4 times 6.25 is equal to x squared. X is going to be the square root of whatever all of that is. So 4 times 6.25 equals 25. And the square root of 25 is 5, and you're done. Okay, number 3. Number 4, let's take a look at this one. It looks like just color the legs and do Pythagorean's theorem. So put an x squared, so it's going to be 6 squared plus 8 squared is equal to x squared. X is going to be the square root of 36 plus 64. It looks like 100, and the square root of 100 is going to be 10. Pretty simple on that one. This one right here is also Pythagorean's theorem. So what you want to do is color the legs, and you want to do x squared plus 15 squared is equal to 17 squared. On this one, you're going to have to subtract and then take the square root. All right, let's keep moving. We're 3 minutes into it and counting. This one right here, number 6, it says find the, find the perimeter. So they want the distance around it. So this is 1, because you can just count one box. This one is 1, 2, 3, 4. It looks like 1, 2, 3. This one is 4. And then you're going to have to do the distance formula here, okay? So you got to go from this point to this point and do the distance formula like this. So it's a little bit of work. This point is over 0 up 1. This point is over 0, 1, 2, 3, 4, 5, 6, over 7 up 4, it looks like. So it's going to be x's in this one, so it's going to be 0 minus 7, and then 1 minus 4. So that's going to give me negative 7 squared is 49. This is going to be a negative 3 squared, which is 9. And when I add that up, I get the square root of whatever that is, 58. So 58 shift square root. So the distance is 7.6 from here to here. Now you got to do the distance point formula from there to there. So let's just finish this one up. This one is 0, 1, 2, 3, 4. So it's over 4 up 0 for that point. And this point right here is the same one. So I think it was 7 and 4. Then you got to do the distance formula on that one. Make sure you understand this one, okay? It's on the EOC. So it's going to be 4 minus 7, and then 0 minus 4. And when you do that, that's going to give me a negative 3 squared, which is going to be 9. And negative 4 squared is going to be 16. That gives me the square root of 25, which equals 5. So this distance is 5, and then you add it all up, and you get your perimeter. So this is 5, 4 plus 1 plus 5 is 10. So it's going to be 17.6 is what I'm going with. And that's inches, and that's perimeter. Okay, so you got to do the distance formula twice on that one, number 6. Number 7, a triangle has those sides. Is it a right triangle? Well, you got to do a squared, b squared, and c squared. So you're going to say 27 squared plus 79 squared. Is that equal to 84 squared? If it is, then yes, it's a right triangle. So let's try it. 27 squared is 729. 79 squared is some huge number, is 6241. And then 84 squared is going to be 7056. Okay, so I'm going to add up these two and see if I get that. So 729 plus 6241, and I get 6970. So it's not the same thing. And since it's not the same thing, you're going to say not a right triangle. Okay? And that's how you do that. Let's keep moving. Number 8, it says find the length of the hypotenuse. This one you could use trig on. This is your hypotenuse. I'm going to go ahead and use trig. So I'm going to stand right here, and I'm going to say opposite over the hypotenuse. So I'm going to say the sine of 45 degrees is equal to the opposite over the hypotenuse here, which is x. I'm going to cross multiply or switch these two, and I get x equals 3 square root of 2 over the sine of 45. And whatever that is your answer. So let's go ahead and work it. 2 shift square root divided by 45 sine, press equals. I get 2. So this side right here is 2. Let me make sure that seems right. 3 times the square root of 2, let's see what that is, just to check on it, times 3. All right, so that's 4. So something is not right. It's got to be bigger. The hypotenuse has to be bigger. So let me think and see. So it is opposite and hypotenuse, and it is the sine of 45, and then it's opposite over the hypotenuse, and I switch these two. I don't see anything wrong with that, but maybe I did something wrong here. So 2 shift square root times 3, press equals, and then divide it by 45 sine, press equals. I get 6 this time. Okay, so I knew something wasn't right, and there it is. I had it set up correctly. I must have just punched it in wrong in the calculator. Let's look at this one. This one also I would use trig. I would use the sine, opposite, and hypotenuse. Okay, you can do that one on your own. This one you could use special triangles if you want. Remember 1, 1, square root of 2. So put your bubbles. Okay, so this is a 45, 45, 90, and the legs are equal. So this one is 8, because it's an isosceles triangle. So all I need is this one. So it's going to be across from the 90, it's going to go the square root of 2, and these are the same. So it's going to be 1 and 1. Okay, so I'm going to have 1 over 8 equals square root of 2 over x. So x is equal to 8 square root of 2. And you can use your calculator on that. If you need to, slow the video down, replay it. Find the length of D in simplest radical form of a cube. Well, a cube, let me think here. There's no picture on this one. All right, and so I don't know about that one. You might have to skip that one. Hopefully I omit that one. This one right here, it says find the values of x and y. Let me think about this. Okay, so what I would do here is I would separate this into two triangles. And I would call this piece A and this piece B. And here's X. Okay, so this is a 45, 45, 90. And this triangle over here looks like this. This is a 30, 60, 90. And you can use trig or special triangles. So I'm going to call this one B. Okay, so what I want to find is this one right here, which I'm going to call C. If I find C and B, I can move the C over here, and then I can do special triangles to get A, and then add up A and B to get my answer. It's a lot of work. So let's take a look here and let's work it. So if I'm standing here, this is opposite, and I'm calling this one C. So it's going to be opposite over hypotenuse here. So it's going to be the sine of 30 degrees is equal to opposite over the hypotenuse. That's going to give me one answer. This one is the adjacent over the hypotenuse, so that's the cosine of 30 degrees is equal to adjacent over the hypotenuse, which is 32. I'm going to go ahead and get 34 times the cosine of 30 is going to be B, and then this one is going to be 34 times the sine of 30, which is going to be C. Let's take a look at that. It's a lot of work here, but we can do it, okay? So what you're going to do here is press 30 and then sine and then times 34. And when I do that, I get 17. So C is equal to 17. So I'm going to put a 17 right here and a 17 right here. And then I need B, so I'm going to do 30 cosine times 34. You really need to know your trig on this, and I get 29.4. So this one is 29.4. Let me just double check just to make sure. So 30 cosine times 34. And it is correct. All right, so now I got to find this one down here, which I called A. So if I stand here, it's going to be opposite over adjacent. So I'm going to say the tangent of 45 degrees is equal to opposite over adjacent. And then I'm going to switch these two. So I'm going to get A is equal to 17 divided by the tangent of 45. So this one is a wing dinger here. So 17 divided by 45 tan, press equals, I get 17. So this piece is 17. So to get Y, you're going to add these up. Okay? And so you still have to find X. Let me think about that. X is going to be opposite over adjacent. So I'm going to say the sine of 45 degrees is equal to opposite over the hypotenuse is what it is. Opposite over the hypotenuse. And that's going to give me X. So switch these two, and I'm going to get X equals 17 divided by the sine of 45. So I'm going to take my calculator and press 17 divided by 45 sine, press equals, and I get 24 on that one. So this one is 24. Put a star by this one. It's a lot of work. You have to start with this triangle first and find these two measurements, and then move this one over here, and then you got to find those two measurements, and then you got to add these two up. And that should give you everything you need. All right, we're going to draw a square for number 13. So when you draw a square, the diagonal, the area is this. Okay, so side times side equals area of a square. Okay, or side squared is equal to area. They tell you the area is 98, so you're going to substitute into that, and you're going to do the square root. So the side is going to be the square root of 98. So this side is the square root of 98, and so is this one, the square root of 98. And they want the diagonal, so put an X there. I would use Pythagorean's theorem. So I would say my legs squared plus my legs squared is equal to X squared. So X is going to be the square root. These cancel, so I get 98 plus 98, and then I'm going to add that up. This is going to be a real challenging test here. Plus 98 equals that, shift, square root, I get 14. So the diagonal is 14, number 13. All right, number 14. A piece of art is in the shape of an equilateral triangle. So an equilateral triangle means all the sides are the same. It says the triangle side is 6, so put a 6 there, and this whole side is 6, but if we split it in half, that makes that 3. It says find the area of the piece of art. Area of a triangle is 1/2 the base times the height. So you know your base is 6. That's this one down here. We need the height here. So we're going to say 1/2 the base, and we need the height. So to get the height, I would use Pythagorean's theorem. I would color my legs like this and say x squared plus 3 squared is equal to 6 squared. So I'm going to say x is going to be the square root of 36 plus 9. So let's add that up. 36 plus 9 equals that. Shift square root. I get 6.7 right here. That's your height times 6. Press equals and then divide by 2. I get 20.1 on this one. Okay, again, this is a wing dinger. Got to be ready. Okay, this next one is actually kind of easy. It says write the tangent ratio. Well, tangent is TOA, opposite over adjacent. So P is right here. So opposite over adjacent would be 16 over 20, and you got to reduce it. And then Q is right here, which is opposite over adjacent would be 12 over 16. And then again, you got to reduce it by 4. 4 goes into 16, 4 times 4 goes into that 5. 4 goes into 12, 3 times 4 goes into that 4. Make sure you reduce. Write the ratio for the sine of x. So here's x. Sine is so, opposite on top of the hypotenuse. So the opposite is this, and the hypotenuse is 12. So that's going to be the square root of 119 over 12. And then you can do the other one. Now let's keep moving. We got more work here. So if you look here, you're going to stand here. It's going to be opposite over adjacent. So it's going to be the tangent of 40 degrees is equal to opposite over adjacent. You're going to switch these two and get x equals 4 over the tangent of 40. Use your calculator and then go ahead and check your answer. This one right here, let me think a minute. Okay, so what would I do on this one? Well, what I would do is I'd start here and I would skip this line for now. And I would go opposite over all of this. And let me see. Maybe I better get W. So I would start here and say opposite over adjacent. So I'd say the tangent of 42 degrees is equal to opposite over adjacent. Switch these two. So W equals 12 over the tan of 42 degrees. So I'm going to take 12 divided by the tan of 42. I'm going to hit tan here and I'm going to press equals. So I get 13.3 is W. So this one is 13.3. Now, if I stand here and I use the great big triangle, then I have opposite over adjacent. So I'm going to say the tangent of 27 degrees is equal to the opposite over the adjacent. The adjacent is going to be 13.3 plus x. It's going to be all of that. Okay, so let me think here a minute. I'm going to go ahead and multiply here. So I'm going to multiply that and get 13.3 plus x. And then I'm going to divide by the tangent of 27. Okay, and now to get x, I got to subtract 13.3. So I'm going to get this minus 13.3. I guess we can finish this one up. So take 12 divided by 27 tan, press equals, minus 13.3. These are pretty tough, so I'm going to get 10.3 as my answer on that. All right, let's keep moving. This one right here is trig. It's an inverse function, so it's opposite over adjacent. So it's the tangent of angle x is equal to opposite over adjacent. Now I'm going to divide by the tangent and get the inverse. So x is going to be the inverse of tangent. So you have to hit the shift sign on that one. You can check your answer. This one is going to be opposite over hypotenuse, so that's going to be the sine, and then it's going to be the inverse sine. So it's going to be the inverse sine of opposite over hypotenuse. And that should work. 21, I guess we're getting close. I hope we're getting close. This one right here, I would do opposite over adjacent. So that's going to be the tangent of 60 degrees equals opposite over adjacent. I'm going to multiply by 5, and then you can check your answer. Okay, that should work right there. It's just trig. This one right here, find x and y. I would start here, and I would go opposite over the hypotenuse. So I would say the sine of 30 degrees is equal to opposite over the hypotenuse, 16 square root of 3. I would multiply that and get y. So 16 square root of 3 times the sine of 30 degrees is equal to y. And then you can do x using adjacent over hypotenuse. So that one would be cosine. This one right here is more trig. You're going to stand here opposite over hypotenuse. So that's the sine of 20 degrees equals opposite over hypotenuse. You're going to switch these. So your answer is going to be 19 divided by the sine of 20. So this is taking me 21 minutes. Some of these are pretty hard, so you might want to skip some and then come back to them. I say we finish it up because we're almost there. Let's take a look here. She dives 2 kilometers or drives up 2 kilometers up a hill. So draw a right triangle. Okay. So I'm going to say 2, the angle of elevation is 9 degrees with the horizontal to the nearest kilometer, find the horizontal distance. This is the horizontal distance. So it's going to be adjacent over hypotenuse. So it's the cosine of 9 degrees equals adjacent over hypotenuse. Multiply by 2, and you're going to get 2 times the cosine of 9 degrees should be your horizontal change. And then finally, or nearly finally, it says that this angle of the depression is 5 degrees. So the angle of elevation is 5 degrees. Remember, those are equal. So you want x, so you're going to stand here opposite over adjacent. So it's going to be the tangent of 5 degrees is equal to opposite over adjacent. 4629, you're going to multiply 4629 times the tangent of 5 degrees, and whatever you get is your answer. Okay, that one wasn't that hard. This one, again, the angle of depression is the same as the angle of elevation. And so what you're going to do here is stand here. So it's going to be opposite over hypotenuse. So that's going to be the sine of 40 degrees equals opposite over hypotenuse. You're going to switch these two, so you're going to get your answer as 500 divided by the sine of 40. And you're done. Use your calculator, rework these. These are kind of tough, but I told you that the trig test is tough. All right, so that's your test for that. Let's move on to MCR. Actually, I'm going to run short of time, so I'm going to stop here for now.